Separating components of heterogeneous mixtures. What are heterogeneous mixtures? Heterogeneous mixtures are those mixtures where the components do not mix completely, or we can say that the components after mixing, they don't have uniform composition throughout. That is what is known as heterogeneous mixture. Now, separation of two immiscible liquids. What is the meaning of immiscible liquids? Immiscible means that which does not mix. Does not mix. That is known as immiscible liquid. And so they are non-uniform mixtures. So they do not mix and they are immiscible liquids. Now, if they are immiscible liquids, how can you separate them? You can separate them based on the properties of the liquids. Now, here one such separation is given of immiscible liquid by using I will say an apparatus which is known as separating funnel. So the apparatus is separating funnel, and the liquids are separated on the basis of their density difference, or rather on difference in density. So the one which is having higher density will be at the bottom. So they have high density will be at the bottom, and the one which is having lower density is at the top. This is how it is being separated. Now here you see, similarly sand and water do not mix, so they form heterogeneous mixture. Now iron filling sulfur, they do not mix, they form heterogeneous mixtures, and there are methods of separating these components, right, in the heterogeneous mixture. So the one which you are seeing in the figure, that is separation of two immiscible liquid, and the two liquids that are taken are mustard oil and water. They do not mix, oil doesn't mix in water. So when you take it in this thistle funnel, you will see it is tapered at the bottom, right? So it's having this tapered shape, a round over here and a tapering over here. Tapering means becoming narrow, with a knob attached over here. So this knob is called the stopcock. So when the two liquids are separated, say this is A and this is B, they are separated on the basis of difference in density. The one which is having higher density is at the bottom, and the one which is having lower density is at the top. And after some time, when you see distinct layers of separation, you can just make the bottom liquid to flow out by opening the stopcock, and you can restrict liquid A from flowing out. So what you have done is, inside the separating funnel is still you are having liquid A, and you have separated liquid B from it. So this is how you can separate two immiscible liquids using separating funnel. Now here you see there is gas particles are free to move. See, here there is a question. Can you think of any heterogeneous mixtures with a gas as one of the component? See, gas particles are free to move in all direction, so they mix very easily and uniformly with other gases. So one gas can easily diffuse into the other. So most of the mixtures of the gases are homogeneous, right? Such as the mixture of hydrogen and oxygen, which is used as rocket fuel. So in rocket fuels, you will see you have hydrogen and oxygen being used. On the other hand, smoke. What is smoke? Smoke is having solid particles suspended in air. Smoke is having solid particles suspended in air. What is fog? Fog is having tiny liquid particles, that is the water vapor in air when it is present. That is known as fog. And dust in the air. These all are some heterogeneous mixtures with gas as one of the component. Right. Now there is another question. What is said that two immiscible liquids of the same density are mixed in a separating funnel. How will the layers form? Now, if they have same density, obviously they will not get separated in a separating funnel forming layers because they are having same density. Now, you can distinguish if they have different colors, but if they don't have different colors, you cannot distinguish them also. So for such liquids, you have other methods of separation. Other than density, you can use solubility as one of the component. Okay. So now the methods of separation will change for such case. Now you can use, see, most of the solid-solid mixtures are heterogeneous. You can use a property of one of the solid to separate the mixture. That means when you have two solids forming the heterogeneous mixture, you can use the property of the solid where one is giving one such property, the other is not giving. Okay, like to separate iron nails from sawdust, obviously you will use magnetic separation where iron nails can be separated using a magnet. So what method you will use is magnetic separation. Next, you have another method called sublimation. Now you need to know what is sublimation. Sublimation is the direct conversion from solid phase to gaseous phase, and gaseous phase to solid phase without undergoing the liquid phase. That is, it is the direct conversion of the solid phase to the gaseous phase and the gaseous phase to the solid phase without going into the intermediate liquid phase. And sublimable substances are camphor, naphthalene. You know, ammonium chloride is also sublimable substance. Ammonium chloride, it is also sublimable substance. Iodine, that is also sublimable substance. So here one experiment is being done where crushed camphor and sand is being taken. It is being taken as a mixture and is being taken in a china dish. This is the china dish. Now here this mixture is taken, placed it on the tripod stand using a wire gauge. Now take a clean and dry funnel. A funnel is being used, kept upside down, and this mixture is being heated gradually. When you heat, what do you observe? The inner wall of the funnel, if you observe, you will see solid deposits. First you will see vapor, and then after some time when the vapors cool on this region, in the stem part of the funnel, you will see solid particles. Now the function of this cotton plug is to restrict the vapors from moving out, right? So what do you observe? You observe solid deposits of camphor. If you have taken camphor and sand, then you will see solid deposits of camphor on the upper part of the funnel. Now you may find white solid camphor deposit. Why? Because when the vapors of camphor went up, it cooled down and it has got converted to the solid phase, right? Now camphor on heating, of course, below its melting point, will change directly from its solid state to the vapor state without undergoing into the liquid state, and this process is known as sublimation. On cooling, the vapors condense back into the solid state, and this is called the deposition. So you have seen sublimation taking place, condensation also taking place, and camphor sublimes and separates from sand because sand is not a sublimable substance. So when you have camphor and sand, you have to see the properties of the solids, and when you see the properties of the solid, you see, okay, camphor is sublimable, and so you can use this method of sublimation in order to separate camphor from sand. Similarly, when you have solid carbon dioxide, this is also known as dry ice. So what is dry ice? Dry ice is solid carbon dioxide, and it is used for storing ice creams, okay? And so which is used for ice cream storage. It also undergoes sublimation. Dry ice also undergoes sublimation, right? So this is how it is being used. Metals do not dissolve into each other at room temperature, but if you melt it at a higher temperature, yes, they do dissolve and give you a separate entity which is known as alloy. So what is an alloy? So what is an alloy? An alloy is a homogeneous mixture of two or more metals, or a metal and a non-metal, right? So it is a homogeneous mixture of two or more metals, or a metal and a non-metal. Since it is homogeneous in nature, physical methods cannot separate the components, right? And they are generally prepared to produce materials that are stronger, more rigid, and corrosion resistant. That is, to improve the property of the metal, they are converted to their alloys. And what are the examples of alloys? Brass is an example of alloy. Okay, so brass is an example of alloy, and you see over here, it is a mixture of copper and zinc. 80% copper and 20% zinc is brass, right? A mixture of 80% copper and 20% zinc. Stainless steel, usually a mixture of iron and other elements such as carbon, traces of carbon is there, chromium is there, nickel, molybdenum, they are all there in these percentages. So you need to know the composition of brass, you need to know the composition of stainless steel, and they are alloys, they are example of alloys. There are question over here, see question number 7 and 8. Why do immiscible liquid form two separate layers in a separating funnel? Well, two immiscible liquids, that means they do not mix, they form two separate layers on the basis of difference in their densities. On the basis of difference in their densities. Next question. Is sublimation different from evaporation? Of course, for this you need to know what is the meaning of sublimation and what is the meaning of evaporation. Sublimation is a process of conversion of solid to the gaseous form and gaseous form to the solid form. Though we have seen that one is named as sublimation and the other is named as deposition, but keep in mind the interconversion between the solid to the gaseous phase without undergoing to the liquid state is known as sublimation, whereas evaporation means a liquid going to the gaseous phase or the vapor phase. That is evaporation, and this is how they are different. They are not the same, right? Moving on to suspension. What are suspension? They are the heterogeneous solutions, right? When you see one of the component is not mixing and settling down, that forms a suspension. So they are heterogeneous mixtures in which solid particles, say sand is an example, and they do not dissolve but remain suspended throughout. That is known as, that is, they do not dissolve, remain suspended throughout the bulk of the medium. Say if I take water, that is known as suspension. So what is important over here is they are heterogeneous mixture, they do not dissolve, they remain suspended. Example is sand and water, where sand particles are highly dense in nature. So when I say sand and water, the basic thing is they form a suspension, that is heterogeneous mixture, where the density of the sand particles are high and they settle at the bottom. They settle at the bottom because they are not dissolved. Sand particles are undissolved. They are larger in size, having high density, and they settle at the bottom, and it is very much visible to the naked eye. You can see in the beaker, if it is containing water and sand, you can very nicely recognize, okay, the sand particles have settled down in a solution containing sand and water, which is heterogeneous. It is not mixing. Now, if you allow the sand to settle for a moment, then you can see separate layer, that is clear liquid at the top, clear water, and sand getting settled. Now you can use the method of decantation, where you can just make the supernatant liquid. I said supernatant. Supernatant means the liquid at the top of the sand to flow out neatly and sand remaining over there. Now, how can we separate mud from water? At times you see mud water, sand and water, and mud and water, they are not the same thing. When you keep muddy water undisturbed, then you see the heavier mud particles settle at the bottom and water may still appear cloudy. Like if you take clear sand and water will separate. But if you take mud and water, that will form a muddy water where it appears to be heterogeneous. Mud will be settling at the bottom, but the water at the top will not be so clear, but it will appear cloudy. Now, how can you separate this? You can now filter the muddy water through a cotton cloth or filter paper. Now, when you do this, while some large particles will be removed, water often remains cloudy. The filtrate often remains cloudy. This shows that filtration is not always enough to separate the tiny particles. Though you can use filtration method to separate sand and water, though you can use filtration method to separate sand and water, when you take mud and water, you cannot use this method of filtration, right? Let me go back to that topic over here. Yes, so you cannot separate mud and water. So for that, what will you do? This shows that you cannot remove the mud water in that manner. Okay, you cannot use the filtration. So what will you do? See over here, this shows that filtration is not always enough to separate tiny particles. Now, if the muddy water is still not clear, even after keeping for some time, what can you do? You can use a method which is known as centrifugation or coagulation. So learn these two terms over here, centrifugation and coagulation. This is centrifugation and this is coagulation. These are the two terms. Now you need to know what are they. What is a centrifugation method and what is a coagulation? So the first thing is centrifugation. Now here we can see that centrifugation means applying. This process involves spinning a mixture in a tube at high speed. Now you have taken it in a glass tube, the mixture that you need to separate the components from, the components you need to separate, and you rotate it at a high speed. Now during centrifugation, the tubes become horizontal and the centrifugal force, which is the outward force acting on a body moving in a circular motion, causes the heavier particles to move outwards, where they settle at the bottom of the tube, while the lighter liquid remains at the top. Now, you have used the mixture and you have kept it in the tube, right? Now here there is the mixture. This is kept in a centrifuge where it is rotated in high speed. When it is rotated in high speed, now it separates in this manner such that the heavy particles are at the bottom and the lighter liquid is at the top on account of the high speed rotation. On account of this high speed rotation. Now this is being seen when you do the spinning game. Suppose you all have done Ringa Ringa Roses wala game, right? So the spinning game is a folk dance or a game which is called Fugari in Marathi and Kikli in Punjabi. And your childhood game, Ringa Ringa Roses, right? Now here you see this game, what happens? If the speed is very high, then you are actually pushed outwards. So this outward force is known as centrifugal force. This is known as centrifugal force, outward force acting on the body which is moving in circular motion. This is the centrifugal force. Right. So when this force is acting, the heavier particles, they move outwards and they settle at the bottom of the tube. So I hope the method of centrifugation is clear. So after centrifugation, we will see what is a special type of centrifugation, not in the machine, but as a paper fuge which you can prepare. If you can use a mini model of it, it is a paper fuge which is being used where you take a cardboard disc, okay, instead of the machine, you take a cardboard disc and what you do is you take a sample. Say when you do blood test, they use this centrifugation method, right? So centrifugation is widely used in laboratories to separate the component of blood such as RBC, red blood cells, plasma, okay, they are being separated. So this is the model of it. A paper fuge can also be used. It is a simple hand powered device. What is happening over here? Here you have taken the sample and now you rotate it. By spinning the sample at high speed, the paper fuge does the same thing. The heavier particles settle at the bottom and the lighter liquid is at the top. Okay, so now here we will see another activity. Make your own centrifuge with a cardboard disc and a thick thread. This is this activity, paper fuge. You can do it. The next method of separation is coagulation. Coagulation is another method of separation, right? So coagulation. What you do? When you coagulate, this type of process of coagulation might be very commonly seen. When you have muddy water, you add powdered alum or fitkari. When you add powdered alum or fitkari, you will see after some time the suspended particles, they settle at the bottom and you get a clear liquid at the top. So on adding fitkari containing muddy water, alum is what? A white crystalline chemical substance often used to purify water. Now this alum causes the fine suspended particles to settle down, right? So this method of settling of the particles by adding something to it is known as coagulation, settling of the particles which is remaining suspended. And alum, which is causing the coagulation, is a coagulant, right? Now these larger clumps thus form, settle by gravity, sedimentation, and then you can separate it by decantation or by filtration. That means these muddy water or the mud from the water was not clearly removed. But when you add a coagulant like alum or fitkari, what happens? The mud settles down and after it settles down by the method of sedimentation, you can easily remove the supernatant liquid by decantation, right? So these are something. The formation of cheese or paneer from milk also involves coagulation, in which acid, lemon juice or vinegar is used as a coagulant and they separate out. That is coagulation of milk protein forming cheese. Now, what are colloids? We have discussed that colloids are the particles having the particle size in between a true solution and a suspension. That is, the colloidal particles are not as small as that of a true solution and is not as big as suspension particles, right? So their particle size is between that of true solution and suspension. So that is what is colloid. Now here, if the components of blood can be separated by centrifugation and the blood coagulates, then is it a suspension? That is a question. Do you think it is a suspension? We cannot see blood cells with the naked eye. So visibility is not there. So can we say it is a suspension? Had it been a suspension, we could have seen the blood cells with the naked eye. Now blood is neither a solution nor a true suspension. What is it? Blood is a colloid. Now some other examples are milk, tomato sauce, ice creams. These all are colloids. And what are the properties of colloids? Their particle size is intermediate. They cannot settle down. The particles which are suspended, they cannot settle down. They are not visible with the naked eye. And do they show Tyndall effect? That we need to see. What is Tyndall effect? Before that, we need to see this part which says donate blood. Donating blood saves life. Have you ever donated blood? If not, come forward. That's a very noble thing to do. People in emergencies, during surgery or with serious illness, they need some blood transfusion. And human blood is the only alternative they can be given. So this transfer of blood from a healthy person to a patient is the blood donation. Now the donated blood needs to be tested first before its group identification. Now it is separated into its components to see, like plasma, platelet, white blood cells, red blood cells. These components need to be tested, right? So these are the components. Now these are stored safely in blood banks and supplied when required. The body replaces the donated blood naturally within a few weeks. It doesn't mean that if you donate blood, you will run short of blood, because your body will make blood again. Okay, so these things we have seen. What is the difference between solution, suspension and colloids on the basis of particle size? So see, the particle size of a solute is smallest, that is less than 1 nanometer in diameter in a solution, and it is larger, greater than 1000 nanometer in diameter for suspension, and within this range 1 to 1000 nanometer it is for colloids. So unlike suspension, the particles of a colloids, they do not settle down over time. So if they are not settling down, so are they stable? No. Okay, so they are uniformly dispersed throughout the mixture. Okay, uniformly distributed throughout the mixture. So can you see the colloidal particles through the naked eye? You cannot see the colloidal particles in the naked eye, through the naked eye, right? Now the colloidal particles remain uniformly dispersed, for which we can say they do not separate and they are stable. Okay, so why stable? Why stable? Colloidal particles are stable. Why? Because they do not separate. Okay, they have the same electrical charge and they do not separate. Now you will not understand maybe about the electrical charge, which you will understand later on. As of now, they do not settle down. So this much you can keep in mind, for which we will say they are stable in nature, whereas suspension, no, they are not stable. True solutions are also stable because the particles will not settle down. Now I was asking, do they show Tyndall effect? What does it mean? The scattering of light by particles is known as Tyndall effect. Now it is so called, it was first explained by the scientist John Tyndall, who studied the scattering of light by particles, and so they are known as Tyndall effect. This phenomena is known as Tyndall effect. Now, light to get scattered, for this you need the particle size. Okay, the particle size should be sufficient such that they can scatter the light. So suspension, the particles of suspension will scatter light, and the particles of colloids will also be able to scatter light, but not the particles of true solution. Okay, so scattering of light occurs when it passes through a colloid or a suspension, but not when it passes through a transparent solution or true solution. Remember that the scattering of light by the particles of solute in a suspension should be greater because they are having greater particle size. Now, the components of a colloid are called dispersed phase and dispersion medium. So, dispersed phase and dispersion medium form colloids. So, I can write dispersed phase and dispersion medium form colloidal particles. So, they form colloids. Right? Now the solute-like component or the dispersed particles, they are the dispersed particles, and in a colloid they form the dispersed phase, and wherever they are dispersed, that is known as dispersion medium. Okay, so some common colloids we encounter, okay, in our daily lives have both dispersed phase and dispersion medium as liquids. So what are they? These are called emulsions. When both dispersed phase and dispersion medium are liquid, they are called emulsion. Emulsion means the dispersion medium is liquid and the dispersed phase is also liquid. Emulsions containing oil and water are further classified as oil in water or water in oil forms, depending on the nature of the dispersed phase and dispersion medium. Now, milk is an example. So milk and vanishing creams are common example of oil in water emulsion. Oil in water. That means dispersed phase is oil and dispersion medium. Dispersed phase is oil. So dispersion medium is water. Now, whereas butter, body lotion, cold cream, they are what? Water in oil. So keep this thing in mind. Oil in water emulsion. They are what? They are milk, they are vanishing creams, and butter, body lotion, cold cream, they are water in oil. That means water in oil means the dispersed phase is water, dispersion medium is oil. Okay, so this is what some medicines are prepared as emulsion to disperse them in water and make them easily palatable. So this also reduces the greasy feeling of the liquid medicine. The presence of emulsifying agents stabilizes emulsions. That is, emulsions are at times stabilized by adding emulsifying agent. Protein in milk and butter acts as emulsifying agent, right? So this is it. So clouds are made up of tiny water droplets, right? So you have seen that clouds are made up of tiny water droplets or ice crystals floating in the air. Based on what you know about solution, suspension and colloid, what type of mixture do you think clouds are and why? So clouds are what type of mixtures and why do you think so? See, clouds are basically colloidal solutions. So they are colloids. Better, they are known as aerosols. Okay, why? Because tiny water droplets or ice crystals are dispersed in air. Because the water droplets, tiny water droplets or ice crystals, they are dispersed in air. So they are colloid. Now air is the dispersion medium and these tiny water droplets and ice crystals are the dispersed phase. Don't write the abbreviations as I'm writing DP and DM. You write the complete forms in your exam. Okay? And why they do not settle quickly like suspension also. Okay? So next question. Why do cities with a lot of smoke and dust in the air often look hazy? Have you seen that they look hazy? Why do they look hazy? Okay. See, they look hazy because the tiny particles present in the air, they form colloid. So, the tiny particles, they form colloids that are present in the air. The tiny particles form colloids and due to this formation of colloids, they look hazy and they are capable of scattering sunlight, of course. They scatter sunlight and due to the hazy appearance, the visibility is reduced. Okay. So next, the difference in the solution, suspension and colloids based on their properties like nature, whether a solution is homogeneous or heterogeneous. Obviously, I think solution, you will say, is homogeneous. What about suspension? Heterogeneous. What about colloid? Is colloid a homogeneous or heterogeneous substance? So what is it? Is colloid homogeneous or heterogeneous? So a colloid is heterogeneous. I think you remember, because even though they appear to be homogeneous, the particles, they do not completely get mixed. Particle size, visibility, separation, settling and Tyndall effect. I think we have discussed all of them. So it can be solved. So these are the summary of what we have done. Go through the summary and post your queries in the comment section. And do like, share and subscribe. Thank you all of you.